Did it put the ice in the radio?
What'd you roll over in your sleep for? Where's that other chucklehead?
Hey, fellas! Hey, fellas! I'm stuck! Defrost me!
Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. How could you not have fun when you're starting a show with a little bit of Three Stooges and some HVAC education? Well, thank you all for joining us. Welcome to Did You Know? The ESCO HVAC Show. And man, have we really had some great topics to dive into. You know, a couple weeks ago, we spent a lot of time with Kate Horton from Hudson Technologies going over some of this HFC phase down. And I really wanted to dive a little bit deeper into what phase downs and phase outs are. This is a really, really fun topic if you like history. And y'all know by now, I absolutely love the history of our industry. So let's take a little bit of a peek back in time with refrigerants so that we can understand why we have transitioned away from other refrigerants in the past, why we are transitioning away from refrigerants that we have right now, and what things we'll be looking at maybe going forward. So if we really dive back into time and we look at refrigeration, refrigeration has a very long history. We were using ether as a refrigerant all the way back into the mid-1700s. So William Cullen did an experiment in 1748 using some ether and water underneath of a glass jar, put a small vacuum and mechanical pump to it, and noticed that there was some ice formations that was coming because of the evaporation of the ether. It wasn't used a whole lot until a few years later when another person, we recognize some names from, Benjamin Franklin, and one of his colleagues, John Hadley, they came up with a demonstration that used ether and alcohol and were able to produce a small device that showed the function of evaporation and could actually produce small chunks of ice, right? So we were using our refrigeration to do mechanical processes. It took a little while before we actually started using that technology in refrigeration. So the first known vapor compression, where we're actually using a compression system to produce our system of evaporation, where we're moving a refrigerant through a process, was back in 1805, right? So in 1805, we had Oliver Evans producing a compression engine mechanical system driven by pumps and created the action that we know of today as vapor compression. And Evans was really involved with a lot of different compression systems at the time. His focus was actually on steam-driven piston assemblies. So he created all kinds of crazy contraptions off from steam-driven pistons. So mechanical contraptions, he built the very first amphibious boat that was back in 1804. But it really didn't get put into principle for the refrigeration that we know until a little bit later. Right? So Jacob Perkins, which was a colleague of Evans, he created the first working refrigerator, right? So the first apparatus that was actually designed for refrigeration. So he had a patent on that in 1835. The patent was for an apparatus and means for producing ice and cooling fluids, right? So if we take a moment and we think about those first refrigeration systems, I want to hear from people in our chat. Also, let us know where you're from. So we want to know, are you here in the United States? Are you joining us from out of the country? Really want to know where you're joining in from. And add this thought. Why did we create refrigeration? What was the purpose of doing that? We're talking 1800s, right? Early 1800s. I'll give it just a second, see if anyone has any thoughts on that. Okay, so what we did is we started using refrigeration for the production of ice. Well, how was that important? Well, if we think back about like the 1830s, right? America was really starting to move west, and to be able to travel those long distances, we needed to have food, right? So we were using food storage methods. Exactly, preserve food. Thanks, Anthony. So we were using ice for preserving food as we were traveling. But if you think about that, it was fine when we were up in the northeast of the United States, but as we were moving west and we were moving south, our ice wouldn't last as long. And the ice that we were harvesting before 1830 was actually coming from lakes and streams, right? Dirty ice. We'll talk about clean ice here in a little bit. So we were using ice that we manually harvested and we transported that, and ice was the foundation for refrigeration. So until then, ice was a commodity, right? We were harvesting it manually, we were taking that ice, we were putting it in transportations, and we were moving it around the country manually. A lot of labor. So the refrigeration changed the way we could manufacture ice. We were even starting to manufacture ice by the late 1870s. 1876, we took a 690-ton cargo ship called the EBO, converted it to one of these mechanical refrigeration systems with methyl ether, right? A very flammable refrigerant. So in today's generations, and we look at our classifications, that would be considered an A3 refrigerant, a hydrocarbon, highly flammable refrigerant. So when people talk about hydrocarbons as something new, not at all. Hydrocarbons have been around since the very beginning. Like the methyl ether, still used in lab and industrial applications today. So we're talking about a refrigerant that's been around for 150 years or so, right? So methyl ether was our first commercially used refrigerant to be able to produce ice. So we started manufacturing very crude devices using ether, very flammable. So if you think back about that time period, that 1800s, we were using a lot of wood. Our buildings were wood. So we were very cautious about having highly flammable refrigerants. So we started working with other refrigerants like this one that a lot of you commercial industrial refrigeration guys are starting to see more of today, right? R744, CO2. CO2 actually came around in the 1860s. It was patented on an 1850 patent by Alexander Twining for industrial ice manufacturing. So when we talk about CO2s, it's being used in our commercial industrial refrigeration applications today. We're just coming back to it. It's always been here. It's never actually left. So some of these early refrigerants were never actually phased down. We just set them on the sidelines for a while because we found some other refrigerants to use. Even ammonia, R717. R717 came into play around 1880, and it was a very efficient, very effective refrigerant for manufacturing ice, right? Oh, I'll hop over here on our chats real quick and get rid of some things. Block. All right.
It's amazing that some of these things that predate most of the equipment we're used to seeing are starting to make a comeback.
Exactly. Things that have been around for a long time. So, we had refrigerants that were flammable. We had refrigerants that operated under high pressures. So we found some other alternative refrigerants, right? One of those was sulfur dioxide. A very efficient refrigerant came into play around 1875 or so. But now we're getting into toxic refrigerants. It's still out there. SO2 is a refrigerant, but it is highly toxic. So it wasn't an effective refrigerant. So we started phasing down the use of refrigerants like SO2 and things like methyl chloride, R30. Very popular small appliance refrigerants at the turn of the century and up until the late 1920s. So one of the main reasons we got rid of methyl chloride, we phased it down because of its toxicity, and it was so toxic that in 1926, we actually had some refrigerators that failed by design, and we lost the lives of some of our citizens. So we removed methyl chloride from residential applications, but we still used it in a lot of our commercial. So even our early freight trains, our ventilated refrigeration boxes, R30 being used in those at the turn of the century. So now we start looking for some alternatives to our high pressure, our high flammable, our high toxicity. Sounds a little familiar, doesn't it? Right? So Dr. Willis Carrier, around 1922, developed a refrigerant called R1130, which is still out there in use today because there was this growing demand for air conditioning equipment, right? So refrigerants that could be used more in residential applications that weren't as toxic, they weren't as flammable, and didn't operate under high pressures. So we even started having commercials for our newfound love of refrigeration. This is a 1926 refrigerator commercial. So we're starting to move refrigerants into the homes, which was a new thing because up until that point, it was mainly commercial and industrial applications. A lot of that just for ice manufacturing. So we have a wide variety of refrigerants all the way from the 1830s up until the 1920s. Things even like gasoline. Yeah, we used gasoline and isobutane and propane and water, all sorts of refrigerants, chemicals that we were using as refrigerants, and they all had some type of a consequence. High pressure, high flammability, high toxicity. So we started looking for other chemicals that we could use. And Thomas Midgley Jr. created the first non-toxic, non-flammable, non-corrosive refrigerant in 1928, and it was branded Freon, right? We've all heard that name Freon before, tend to relate to a particular refrigerant, right? So what refrigerant are we talking about when we talk about things like R12, maybe? So the refrigerant that we chose primarily in that CFC class was refrigerant 12, CFC 12, but we had a bunch of others that were in that process as well. We had things like R502, but R12 was a very efficient medium and low temperature application. So we put it into things even like vehicles in the 1930s. A lot of people don't realize that we were creating high-end custom auto coaches that had air conditioning in the 30s, but we were. And it was a very, very popular refrigerant for a long time. By the time we get into the 1940s, now we're talking about things like comfort cooling, which a lot of us are familiar with today. That has forever changed the way that we look at our indoor air environments. So our HCFC 22 started becoming extremely prominent in residential applications, particularly small window air conditioners and some of our mobile air conditioners, right? So once we got conditioned air, comfort cooling inside of our structures, the demand for these refrigerants multiplied. All of our CFCs and HCFCs became under very high demand and in mass production. So now once we move a little forward and we get into the 1950s, by the 1950s, we have already moved commercial refrigeration or residential refrigeration into the kitchens of most of America. And they've been around long enough, we're now starting to see commercials trying to encourage you for custom upgrades to your current refrigerators. So CFC 12 now moves into a glamour mode for refrigeration, and we start the cycle of custom home components, home devices manufactured for refrigeration and for air conditioning. And so what we think of today as our modern refrigeration industry boomed, and it boomed like crazy, and it still does till this day. So when we start talking about that refrigeration expansion, how America started moving towards mass production of refrigerants, we actually had a lot of campaigns. Let me go ahead and pull this this campaign up. This was in 1953.
Friends, ever since we presented the
DeSoto
brilliant DeSoto
commercial.
automatic on this
Very
show,
interesting. You got to take a
people
look at this.
everywhere have been asking about one particular feature of this great car. Oh, sure, they want to know about Power Flight fully automatic transmission, about remarkable DeSoto full-time power steering, but
Big
they
deal,
also want
automatic
to know
transmissions
especially
and power
about
steering.
revolutionary DeSoto air conditioning.
Check this one out.
Well, here's the story. You see that vent there on the side? That's the fresh air inlet. Air is taken in there, filtered, cooled, and dehumidified by the air conditioning unit placed on this ledge. By the way, the unit takes up very little
So we
usable
still have a
luggage
compressor,
space.
belt-driven compressor
Bad
in the
air
engine
is removed
compartment.
here.
And now we've moved our air exchange assembly,
And
our
clean,
evaporator
fresh
assembly,
air is blown
into the back
gently
of our
from this
cab.
vent throughout the
Ducted air
interior of the
conditioning.
car. Stale air, odors, tobacco smoke are quickly dispelled, leaving the DeSoto interior crisp, cool, and comfortable.
Pretty interesting, huh? So we're talking 1950s. So this revolution of air conditioning and refrigeration components. And when we think about automotive air conditioning, a lot of people think, oh, by the 1970s and the 1980s, we started putting air conditioning in vehicles. No, we started in the 50s. And in the 60s, it went crazy. By 1969, more than half of all new cars are being built with air conditioning. And the dominant refrigerant at that time was CFC12, R12, right? And in that same time period in the 1960s, we're developing the American interstate travel system. So people are traveling all over the country, all over the world, using automobiles, air conditioning them. So we're going through refrigerants like crazy to build these new comfort zones, right? Well, things start changing.
Clifton, real quick before you get to the 90s, I'm going to
Yes.
point out that in the 60s, 50s, and 60s, if you looked at the population of the United States in the Southwest, where what we call the Sun Belt,
Yep.
if you looked at that entire area, there was like maybe 1 million people living there because, again, of the extreme temperatures, how hot it gets in the summer. And with the advent of the air-conditioned car, the window air conditioner, and then the home air conditioner, we see the explosion of people moving to the Southwest, as you mentioned.
Mass migration.
The population from the 50s to the 60s to the 70s quadrupled down there because of air conditioning. It allowed us to live in areas that were before just extremely, extremely uncomfortable.
Changed our climate indoors.
So air conditioning in the cars, air conditioning in the homes. Remember, it used to be a luxury. It used to be only in the movie theaters.
Exactly.
And we would go, well, not we, but the folks then would go sit and see a double feature just so they could sit in the air conditioning. And in the 50s and 60s, it exploded into the residential market where we see it in homes and cars and those sorts of things. So it did help us kind of fan out into areas that we never considered living in before.
Sure. I mean, when we look at that initial migration, when we were just needing to get food to last longer, to move into places across the U.S., well, now we had some mobile ice. Ice was easier to manufacture. We didn't have to get it from the north and the northeast. We could manufacture ice anywhere in the country if we had a mobile refrigeration plant. So then as time moved on, we started moving all towards the west, exactly, in the Great Expansion like you're talking about. We started having homes that were getting fairly large, and with the advent of air conditioning, now we can control the climates in those so that they were tolerable year-round very easily. And it created a huge demand for CFC and HCFC refrigerants. So great point, Jason. Absolutely. So as we started moving into the 1990s, we really started noticing some changes in our environment, things that we're talking about a lot today. We were starting to talk about in the 1990s. In the 1980s, we were measuring and starting to look at why the world was changing, why the world was warming, why we were starting to have effects to it. And so we started looking at all of the different contributors to climate change. And we did find that our CFCs were our primary contributors. You know, we've talked about how chlorine contributes to our ozone depletion. So we put into play actions to transition away from CFC refrigerants. And at the time, we still had HCFC refrigerants in the mix that weren't as effective or weren't as destructive to ozone as what the CFCs were. So we had refrigerants in play that allowed us to have a little bit of a transitional window that we're not going to have with our HFCs. So we made very quick changes in our culture in the 1990s to move away from CFC refrigerants and our HCFC refrigerants. The biggest one happened in the automotive industry when we switched from our CFC 12 into our HFC 134A. It didn't happen over a long window like with R22. It happened in an extremely short period of time. So in 1994, we mandated through the Montreal Protocol that we were going to reduce our CFCs by 75% in 1994 and 100% by 1996. a extremely short window of 100% phase out. So what is the difference between phase downs and phase outs? With our phase out, that means we are going down to zero. We are 100% eliminating that refrigerant from use in new applications and in retrofits. So the manufacturing of the refrigerant. So we went very quickly from 100% production to 0% reduction, really in a period of about 3 years, less than 3 years.
Clifton, I'm going to
Yes.
point out real quick that when we say phase out and phase down, this is for new systems and new refrigerants. This doesn't really affect reclamation, recovered refrigerant. Those are
Exactly.
still allowed to be. So if there's a refrigerant in the system, it could be recovered, reclaimed, and resold.
Exactly. So we're talking about new equipment. And we think about vehicles. A vehicle is not like a home. We're staying in a vehicle for a few years, right? So the turnover period on vehicles is usually about 5 to 6 years. So we had to very quickly change the consumption requirements of our vehicles from R12 to 134A. So we actually got ahead of the change, and most of the industry had converted over to 134A by 1995. So we were actually ahead of our schedule on converting our refrigerants because we knew as soon as you make that 75% reduction in the supply of refrigerant, we all know what happens to refrigerant costs, right? Boom, they go sky high quickly. So we went ahead and converted over because we had refrigerants available. We had our 134A available at that time. Now, what about the HCFCs? Remember, the HCFCs still had chlorine, so they were affecting ozone depletion, just not as significantly as the CFCs. So we had a longer window of time that we allowed to be able to phase out, and it was a phase out of our HCFC refrigerants. So we looked at the applications. It depended on the quantity, it depended on the supply of replacement refrigerants, and it depended on what it was being used in. So we look at things like 141. A lot of people don't know about 141, but it was a HCFC refrigerant that was utilized, and we started doing the reduction of it by 35% in 2003. When we look at things that we know, like HCFC 22, R22, right? R22 started its decline, and in 2010, we had our 75% reduction. 2015, we had our 90% reduction. 2020, which is the one that most people know, because by the time 2020 got there, we know what happened with R22, right? Is because of that supply. Our supply diminished, so the price went up. So by 2030, there had to be a 100% reduction. So we're technically still in the phase down period of R22. We're just at 99.5%. That means we have 0.5% of R22 available to be manufactured as what we did before we started this phase out of R22. So by 2030, it is a 100% phase out of R22, which means after 2030, zero R22 can ever be manufactured again. Right now, we're only at 0.5%. And that is the reason that we've seen the escalation in prices of refrigerants. If any of you were in the refrigeration industry, like I was in the late 90s, early 2000s, you've seen what happened to all of these CFC refrigerants. They just went crazy, which encouraged you to switch over to the replacement refrigerants that were available. Same thing in our HCFCs. Now, there are some differences when we talk about that, and that's why we're here today, is to look at the differences between these different phase outs and phase downs. So let's take a look at HFC phase down. That's the one we are in right now, and not everyone even realizes that. Did you know that we are in a phase down of all of our HFC refrigerants?
Clifton, when did that start?
That actually started this year, at the beginning of this year.
So we're already in it.
We're already in a 10% reduction of the manufacturing of all HFC refrigerants. This is not just one or two. This is the entire class of HFC refrigerants, which we're going to look at a few of those here in a minute, just to make sure you are aware of what those are. So has anyone seen an increase in the price of, let's just say, HFC 134A in the last year or so? Has anyone seen an increase in the price of HFC 404 in the last year or so? What about HFC R410A? Right? So we should be familiar. If we're in the air conditioning and residential, commercial, industrial, we know 410A. That's been our primary refrigerant to replace our HCFC 22 for quite some time. It started a 10% reduction in R22 this year. So what's going to happen as we phase this down? Well, we know what happens with the cost of supply when the demand goes down, right? So we're going to stay on a 10% reduction through 2023. And in January of 2024, we're going to hit a very big milestone. We're adding an additional 30% reduction, which means January 1st of 2024, from January 1st of 2022, there will be a 40% reduction in the amount of new HFCs being manufactured. So we can only assume what's going to happen to the cost of HFCs when we hit 2024, right? So we're not here to scare. We're just helping you prepare and understand what these things look like. Because probably like myself, when I first seen R410A prices go up this last year, I went, wow, what happened with R410A? A lot of us really didn't understand exactly what was happening. We didn't realize we were in the phase down, and it was already starting to affect cost of refrigerants.
Clifton, just to piggyback off of what our previous guest Kate said, that this phase down affects manufacture of new refrigerants and importation of refrigerants, but we can help as technicians, as part of the industry, to keep the cost down by recovering refrigerant and getting it in for reclamation. This phase down doesn't affect reclaimed refrigerant. It's new refrigerant that we manufacture or import. Right.
Exactly.
So we're not here to scare you. We're here to motivate you to recover and reclaim refrigerant so we can get it back on the market and help keep that price down.
And recover like you never have before, because that is how we can keep this price down. Like Kate was giving us some examples of realistic numbers of the amount of refrigerant that is being reclaimed in the field and brought back in for reclamation. It's very small. It's much smaller than anyone had actually anticipated. So that means we're not reclaiming like we're supposed to. We're not recycling like we're supposed to. And now we have the opportunity to do that so that we can minimize this effect to our industry once we start hitting these places, these points, right? So we're talking about 2024, then we're going to have another big one in 2029, and then we're going to phase that thing down. We're not completely phasing out our HFC refrigerants, but we are going to have an 85% reduction of those. So that's where we're at. We are stepping down HFCs very quickly. One issue is the amount of leaks in the systems, coming from one of our viewers. You are 100% right. We have all these expectations for repairing leaks in a timely manner, and a lot of that is not taken into perspective of how it affects our total supply of refrigerants. So that's what we're here to do. We're just here to show you how those refrigerants are being affected by our choices in the field to do things properly.
Up until recently, the prices of the refrigerants have been such that it was more economical just to top it off and not try and seek out the leak and repair it. But with the prices going up and the inventory going down, it's going to behoove us to find that leak, repair it, and then recharge the system.
Yeah, not only for us, but it's required by law for one, but for the benefit of our homeowners, our customers that we're actually doing these repairs for. Yeah, here's a good example. Back in the 1990s, you could purchase 10 pallets of R12 at $39 a jug, right? So that's the things that we see is we had to be careful on not hoarding, use what we need, and recover and reclaim the refrigerants, and to make sure to get them back to our reclaim facilities so they can be turned back into reclaimed refrigerant. Because you got to remember that reclaimed refrigerant is being recertified to ASHRAE standards, so it is as good as brand new refrigerants, right?
Circular economy, right?
Exactly. So we can truly affect that price. If we think back about those 1990s, right? What was our main culprit? When we were phasing down and phasing out our CFC refrigerants and the cost of R12 went sky high, did you ever see anybody in the automotive industry recovering refrigerant? Did you see people fixing leaks on vehicles like they were supposed to? No. You went to Walmart and you bought you a can of R12 and you topped it off every time you needed to, right? So we started seeing those similar things even through the 90s. And so by the time we got into our HFO refrigerants, 1234YF, it has really made a significant difference in the way we look at leaks and systems and the designing and the engineer of systems. We don't have as many O-rings that we used to have in our older R12 and our 134A systems. We have tried to manufacture equipment that has less leaks. So when we get into the field, when we were talking about comfort cooling, our air conditioning, and we're talking about refrigeration, it's on us to make sure that our systems are sealed and our leaks are repaired properly. And that's going to be very important going forward, especially when we start talking about more products like ductless that are using flare connections and, proper techniques for sealing systems and verifying that we have no leaks in our systems before we fire them up and release refrigerant into them.
Just to point this out, Clifton, up until now, a system with a leak would operate to a point. It may overheat the compressor, may freeze up, and a technician would come out and top it off and get it back to where it needed to be. But as we transition to replacement refrigerants for the, that we're phasing down here, they're going to be A2L type refrigerants, and those systems will not operate with a leak. They have something called an RDS, a refrigerant detection system. And when one of those sensors picks up a leak, it's going to shut the unit down and put it into lockout. So moving forward, we're going to have no choice but to repair the leak. If you top it off to bring it back up, 5 seconds after you turn to walk away from that unit, that leak sensor is going to pick it up and lock it right back out. You're going to have to find the leak, repair it, and then put the refrigerant back. And we're not going to have a choice moving forward.
No. So as we start looking at our A2L refrigerants, this is going to be the reality of the systems, that they are going to have sensors that are installed into the equipment to look for leaks. And that is going to play a big factor on keeping our systems maintained properly and making sure that our systems are running leak-free. We are going to become a new generation of technicians, without a doubt. And there are going to be some pain points along the way. We're going to be changing our practices a little bit. We're going to be working on equipment that won't allow us to leave less than acceptable installations. We're going to see a lot of changes in this next year. So it's important for us to hang in together as a community and to take a look at these changes and just understand what they are and get back to our basic practices of installation and repairs.
2 points. If you're doing or practicing what we call industry best practices, if you're doing the things that you're supposed to be doing, this isn't going to affect you as much as it does others. And 2, invest in training, because there's things coming out moving forward that are going to require training, and always consider an investment in training as an investment in yourself and your future. It doesn't hurt anybody. It only makes you better at what you do.
Exactly. One of the questions came through is, why are places allowed to sell refrigerant to people who don't have a license to handle refrigerant? Well, some of that goes back into some loopholes that we had in our original designs of our refrigerant phase outs and phase downs. Because remember, we didn't have our EPA license when we had CFC refrigerants at first, right? So as our licenses came into play, it started changing the way the industry and the way manufacturers and the way legislation looked at who could purchase refrigerants. So we've seen a lot of changes with that with our 1234YF. Now with our 134A, there is a lot of 134A out there in less than 16-ounce cans that can be purchased by someone without a license. A big contributor to the reason we had to get control of the entire refrigerant release. A lot of the refrigerant that is being released through automobiles were being done by, back to, poor practices, right? So we are seeing a push for heavier licensing. We have seen the EPA invest in a significant new amount of investigators. So we are going to see changes across the industry like we have probably not experienced before. I know I have not. That's why I'm so passionate about getting this information to you to see what has happened. Because when we look at the charts of how refrigerants have been phased down and phased out over time, the change that is happening right now is not the same as the one that we experienced with CFC and HCFC refrigerants. If we look at the CFC phase down, by the time we got to 1990 and we were phasing out our CFCs, we already had refrigerants in play that could handle most of those replacements, right? We had HCFC refrigerants already there. So it was a matter of making a fast change from CFCs over to HCFCs, and by 1992, we even had HFC refrigerants. So we had a whole supply of refrigerants that could easily transition us from the CFCs that we wanted to get away from, the HCFCs that we wanted to get away from, to get into the HFCs, which most of us in the industry knew at the time. When we went to HFCs, they were not long-term permanent replacements. We knew that when we went from R22 to R410A, yes, we were reducing our ozone depleting potential, but we were increasing our global warming potential. It was a sacrifice that was made for the conditions at the time, right? So now let's take a look at what's happening. Okay, so we're now transitioning out of our HFCs, and what do we have to replace all the HFCs in the industry? Not much, right? We don't have this whole variety of refrigerants.
I'm going to point out real quick, there was a question that came up. It said, will the sensors be located
I've seen that.
in all equipment? The answer is yes and no. It's charge dependent. So the size of the charge will dictate when the sensors have to be there. And there'll be more than just sensors. The larger the system gets, there'll be other mitigations like automatic pump down solenoids and things like that. They'll all be part of a singular refrigerant detection system. And the other point I wanted to bring up is, you said, we knew that these HFCs weren't long for this. When we were transitioning from 22 to 410, the rest of, say, Europe was transitioning from 22 to 32.
Exactly.
The reason we didn't transition to 32 is our building codes and our standards didn't allow for an A2L refrigerant in those applications. So what we did was we took some R125 and put it into 132. Right, 125 is a flame suppressant.
Yes.
So we took R32, put some flame suppressant in there, and boom, we got 410A.
Voila.
And now we don't have to wait. Now here we are a decade or two later. Our building codes are updated, our standards are updated, and we are now starting to roll out these refrigerants. But they're not new to the industry. They're just new to us.
Absolutely not. Just new
They're
to us.
used all over the world, and we're now starting to get on board.
Yeah, and there's a part of that that kind of gets misunderstood, is that, R32 even in itself is an HFC refrigerant. R32 itself will be going through this phase down as well. So we have so much less options for refrigerant than what we did when we were leaving CFC and HCFC. When we were leaving both of those, we had all kinds of blends, and you are going to see blended refrigerants. You're going to see HFO and HFC blended refrigerants. We've already started seeing some of those, right? So our most popular HFOs are things like 1234YF. Our most popular HFC are pretty much R32. We use it in 410, we use it in all sorts of different refrigerants. But those are going to start phasing down over time. So the industry is really in a fast forward push to get HFO refrigerants lined up. We are already using more HC, hydrocarbon refrigerants, in our small appliances with limited capacities. So there is a window of unknown for refrigerants. And I know there's a lot of people that are afraid of that when they go, what refrigerants are we going to? We're just getting there as well as we can at the moment. And we will probably see a variety of different refrigerants in this next year to 2 years as we make this transition. If any of you were in that refrigeration industry in the 90s, you know that it wasn't like we were going from R12 over to 134. We had variety of blended refrigerants depending on the application we had. The automotive industry, it was great. You just went from 12 to 134A. And in many times, you can add an oil, replace oil and compressor, and off you roll. Not so much when we're talking about small fractional horsepower refrigeration systems, right? Wasn't the same when we were talking about commercial industrial rack systems. So we had all sorts of refrigerants in there. Don't be surprised to see a variety of refrigerants coming to the industry. Our primaries are going to be R32 and blends of R32 like 454, right? So 454 is going to be R32 and it's going to be 1234YF. So there are going to be choices. We did. Eugene, you're so right. We had way too many choices. When we talk about refrigerants, it was a normal day for me to have 12, 13 refrigerants on my van. I had all sorts. I had 12, I had 22, I had 410, 408, 409, 414B, I had 500, I had 502, I had recovery cylinders. It got to the point where we had so many refrigerants, we kept most of the non-typical refrigerants at the shop, and we just took them. If we were going to work on refrigeration, we took off the air conditioning stuff, we put the refrigeration on, and off we went. So we may see some more of that, and we don't want you to be afraid of that when you encounter that. It's just part of this process. We're trying to help prepare so we take away some of that pain, because we are in the middle of this HFC phase down. So in all of that, when we start talking about this, what refrigerants would you say are currently being phased down? Do you know? That's why we're here. So throw some in the chat. Give me some options. We've talked about a few, but there's a few more out there that we haven't even talked about yet that are still in that same class. Any thoughts? Everybody being shy today because they're not exactly sure what's going on here?
I think we shocked them a little bit.
I think we did, and it's not here to shock and scare. It's here to shock and be aware. Because when you embrace the changes that are happening, when you educate yourself and you absorb these resources that you have, you are going to have an opportunity to excel at your career. And that's what we want you to do. This community is here for one reason, to help make you better. And so we're going to do that together. So here are just a few. Hey, there we go. Thank you. R22. R22 is already headed out. R410A, 134A, 404, 507, 134A. All of the refrigerants that we now consider normal refrigerants are either being phased down by the manufacturers of equipment, or they're following along suit in the HFC refrigerant phase down completely. Those that are in the commercial industrial that work with R404, they know that pain already. The pain of R404 has been around for a few years already because our manufacturers started getting well ahead of that. The manufacturers of refrigeration kind of stay ahead of the game, right? They keep up with the changes and have been preparing for these refrigerant shifts for quite some time. Our residential comfort cooling products, not quite as much. We're getting there though. So if you worked with any of the refrigerants, any of the 400 series refrigerants, all of the 400 series refrigerants that I'm aware of, if you're working with R134A, the 32, those of you that are outside of the United States, you're probably very familiar with R32. You can actually buy R32 products here in the United States. People don't realize that. But small self-contained systems, Type 1 systems, have been imported into the United States with R32 for quite some time.
2015.
Yeah, so they're here. You can go to a wholesaler and hop on their catalog, and you'll find some R32 window air conditioner units, particularly, and PTAC style units as well, that are out there. Yeah, Juan, yep, 438A, you're still using it, right? On the chopping block. Anything in the HFC class. There are a lot of refrigerants under HFCs. When we typically think about refrigerants, we think about maybe 20 or 50 refrigerants, right? There are literally hundreds of refrigerants from different blends and different azeotropes that are all part of the HFC class of refrigerants. So the entire world is going to be affected, not just our industry alone. Because now we're talking about foam blowing applications. We're talking about other industries that use HFC chemicals, right? Great point, Tom. Automotive industry, they've taken the 1234YF so seriously. 1234YF has been imported in vehicles here in the United States for like a dozen years now, right? So they have really grasped that, understood it, and went right into using these new refrigerants. So there is going to be some learning curves for us. Believe us.
Clifton, I want to point out real quick what helped when you mentioned 404A and that they got out in front of it. One of the things that helped push them, if you will, over the edge was that the state of California got rid of 404A. As a state, they said, listen, no more 404A here in California. And that kind of started all right, well, if they're not going to use it, then I'm not going to use it. And now all of a sudden nobody's making it and the price is going up and it's being phased down. So in my opinion, I anticipate, we're going to see issues with 410A, especially as everyone's, grasping for R32 for other applications. But we're also going to see a huge decline in 404A.
Yeah, absolutely we have. And I honestly would not be surprised to see the 410 regulations going into play in California as well. We hear rumors of that already.
They do have, the bulk sales by 2025. And by bulk, they mean 30-pound cylinders.
Exactly. So what we carry. So Anthony, one of the questions that was brought out by Anthony was, do we know what the best refrigerant low GWPs and ODPs are? So ODP must be 0. Ozone depleting potential must be a 0. The global warming potential is right now in a period
It's a
where
soft target, right?
yeah, it's a soft
The
target.
soft target for comfort cooling is roughly 750 GWP, and when you
That's
get into
right.
commercial industrial, it's 150
Big difference.
GWP. Huge difference.
Yeah.
So again, those are soft targets. There's nothing in writing, but those are the targets that are being, because that's basically what California is using. So that's what
Exactly.
everyone's kind of deferring to. So again, in the comfort cooling, so when you're talking about air conditioning, heat pumps, those sorts of things, it's 750. And when you're talking about refrigeration, industrial, commercial process refrigeration, you're talking about 150. That doesn't leave a lot.
That gets us
Of
pretty much into
refrigerants.
HFOs and HCs.
You're back to CO2, ammonia,
Some of our natural refrigerants.
HFO, 1, 2, 3, 4, YF, right? We're seeing a comeback of those refrigerants that you talked about at the beginning of the show. Ammonia, CO2, propane, isobutane. These are all making a comeback.
Right. And that's the reason I wanted to bring up the history of it, so that we can understand that what you hear, because you will hear people in industry going, hey, we have new refrigerants, right? We have some new flammable refrigerants, A3 class refrigerants, like isobutane and propane, that are already being used in small refrigeration appliances in residential and commercial. They're not new. They've been around for 150 years, some of them. We just moved them to the side because we found what we thought was a much better solution. A non-flammable, non-corrosive refrigerant, CFC class. We thought we were making the right decisions. We realized that we were heavily impacting our environment. It's been scientifically proven over and over and over by every country in the world. We do not dispute that refrigerants are a major contributor to the effect of our planet. So now we are in this fast forward, high responsibility point in the HVAC industry for everyone to contribute to the longevity of our planet. If we don't believe in global warming, all you have to do is open up a newspaper. I try not to, because it's so alarming, the things that are changing because of things that we can have an effect on. So as we move forward as an HVAC industry, we are going to become very much more aware of our environment and our own responsibility. And we have the ability to change even the cost, because we hear a lot of complaints about the cost of equipment, the cost of refrigerants. Well, if we were following best practices, we could actually change that on our own without relying on the industry doing what they have to do, because the industry is going to follow supply and demand, right? It's just marketing. It's just the way the world turns. So if we increase the supply, right, we're going to be able to affect the cost on that. So it's up to us to understand that all of our HFC refrigerants are going to start being produced less and less and less. And it's up to us to supply more and more and more to be able to keep that cost
Through
down.
recovery, right. The other thing I'll
Exactly.
point out, Clifton, you brought up propane, isobutane, and like that. We've already seen them in, corded refrigeration appliances, doors and drawers open, that
Absolutely.
UL standards have just this year been updated to allow for a bit larger charges in
Yeah.
those. So we're going to see a lot more of those doors and drawers and open type refrigeration corded appliances
Yep.
with either R290 or R600A.
I was just looking at a 3-door commercial freezer running on an R290. So we have significantly changed the capacity of the equipment. We've improved the efficiency of the equipment. And so now we're just making the adjustments in refrigerant to be able to compensate for that. So we are doing more with less. And we're going to see a lot of that going forward.
My refrigerator upstairs, I got a brand new refrigerator. Well, last year, it's got 290, 1.6 ounces of 290.
Exactly. Think about that. People go, what's that? I was like, that ain't very much. Just think about how much a Bic lighter holds. And you carry that in your pocket, right? So we can do a lot of work with a small amount of refrigerant when we design the systems properly. So we're going to see our manufacturers making a significant push to higher efficiency systems that operate with less refrigerant to help reduce that cost as well. So it's a balancing act. It's an effort across the board. It's not just one piece of the industry. It is every part of the industry. And it's us as well trying to help educate what these things are so that we're not walking into it going, wait a minute, an extra 30% reduction in R410A and the cost just went up by how much? How could I have affected that? Right here. This is how we affect that.
Leak check.
Exactly. So it's a matter of just understanding, following our best practices, and contributing to the effort to improve it. Because when we look at things like CO2 emissions, which we're not going to dive into today, but we are going to dive into on one of our sessions here in the near future on how we are actually starting to track our entire world by CO2 emissions live. We're actually monitoring the places, the hot spots in our world where we are having higher supplies of CO2 emissions so that we can focus on areas to try to reduce our emissions so that we can get our global warming down, right? And we look at how those emissions, those CO2 emissions, are being affected by different industries. We fall into this Montreal Protocol, right? The Montreal Protocol is the driving force behind what we're doing with refrigerants. And when we see, compared to other sectors and other industries, we are a significant part of the reduction of CO2 equivalent emissions, right? So it does rest on us to become better at what we do, to be able to understand the equipment we're working with, to review the refrigerants that we're going to be using to get a understanding of them before we go there, and to know what refrigerants are going to be able to work in replacements for things that we are already on, because that can be a struggle. If we're not prepared and we walk up to a piece of equipment and we go, okay, I have this refrigerant in it, what do I need to do now? Because those times are going to come for very
one of the things I want to point out too, that you're saying that when we were transitioning from R22 to 410, there were 17 EPA approved substitutes, right?
Yep.
For R22. We're not going to see that moving forward because a lot of these refrigerants that we're discussing, these low GWP refrigerants, are flammable, either A2L or A3.
Yeah.
And you cannot backwards retrofit a system that's an
compatible.
A1 refrigerant with an A2 or an A3, right?
Exactly.
So if we're using an A2L refrigerant, an A3 refrigerant, it has to be in a system designed for use with an A2L.
Has to stay in the same
or an
class.
A3. Right. You can't change the flammability class of a system. If it's an A1 system, it can only have an A1 refrigerant.
Yeah, exactly.
There was also a question up there about the minimum amount for 290 and 600A. It used to be 150 grams. The latest version of UL 2-89 that was published upped it to 350 grams for doors and drawers. So if the system had doors or drawers where it could be closed in, it was 350 grams. And if it was an open system where you could reach in and grab your sandwich or your drink, then it was 500 grams.
Sure.
Now the standard is updated. It has to be accepted into the building codes and accepted by EPA. And the process has started. The standard is written and published. And those are the two numbers. It's 350 for doors and drawers and 500 for open. For A3 refrigerants, flammable refrigerants.
For A3s. And we are going to see a lot more of that. In the when we start talking about grocery refrigeration, we're going to see a significant change in designs. The days where, like I work on a rack system that's got 1,200 pounds of R22 in it, those are not going to happen going forward. So those are going to be legacy systems. They are going to be out there. We're still going to work on those things. Now we're just going to need to understand what refrigerants are going to be able to be used in some of those applications. So we're not talking about changing every refrigerant out there. We're talking about new equipment, the manufacturing of new refrigerant, because our manufacturers are going to look at, what refrigerants are changing and just try to stay ahead of that a little bit, right? So we're primarily talking about new equipment, new refrigerants. But just be aware that we are talking about refrigerants that are already in existing systems. It's going to affect the cost of them. So at some point, we're going to be looking for replacement refrigerants that are less expensive than the current HFC that is in it at the time. All right. So that's where we're going to be. We're going to be more aware of the changes that are around us. And we want you to come back. That's what we're doing this for. We have a lot of things we could be doing in life. We choose to have a community with you. We choose to bring industry experts in every week to talk about the changes in the industry, not just things that have happened and things that we see or just techniques and tools. There are a lot of good resources for that. We want to help you be aware of how to better yourself and prepare yourself for the industry that is evolving around us. So, lots of brain scratchers in there, right? I know, lots of things to come back and rethink about and, put yourself in the position of going, okay, where do I play a part in all of this change? How much is R410A going up one? Good question.
Nobody knows.
The more we take in for reclaim, the less it's going to go up. I'll tell you that for sure. If we don't recover and reclaim refrigerant, the price is going to go up faster than it should.
It was also pointed out while Kate was here that in some areas of the country there were shortages of recovery tanks, and they
Yes.
were asking why is that? And one of the reasons, one of the answers put forward was, listen, there's probably a boatload of recovery tanks just sitting in someone's shop or sitting in the back of someone's vehicle, not getting any use, or holding something that's never going to be reused.
We had a comment on that. I was going to bring that up earlier, that, one of the reasons that we don't have as much refrigerant out there is because a lot of people are just recovering it and put it in their shops, and it's just stacking up because it doesn't really have any value. So you thought, right? And if you would have been with us a couple weeks ago with Kate Horton, you would realize that refrigerant is now starting to become a commodity that you will be able to sell back. So, we're not letting it sit and just pile up because it's not worth our time to take it in. Now we have our reclaim facilities going, hey, that refrigerant's actually worth a little bit of money. And as we go forward, it's going to be worth a lot more money.
They're going to invest in it, right?
Exactly. So reclaiming refrigerant is important.
Buying pallets and pallets and just sitting on them, hoping to make a fortune in the near future. Exactly. And the problem with that is the amount of systems that are going to be left that run on those refrigerants is going to start to dwindle as these years go on.
Sure.
So if you're buying pallets and pallets of refrigerant, just be wary that very soon we're going to see equipment changes, and the amount of equipment that's transitioning out in the field that work on that particular equipment is going to start dropping. Everyone says we're going to buy R22, we're going to sit on it. Well, now there's 17 approved substitutes for R22, and they are way cheaper than buying original R22. So no one's going to pay.
No one wants to buy that.
Right. The same thing may happen with 410A. We don't know. But again, we're here preaching to you that, listen, this is already happening. This happened above our heads, and it comes rolling down the hill. And we're passing the information on to you, right? We're trying to get the information out to you so you can make informed decisions. You can be, again, informed about what's going to happen tomorrow, what's going to happen, what can we anticipate, what do we expect to see in our industry? Well, this is what we expect to see.
This is it.
This is different from previous transitions that we went through, from the CFCs to the HCFCs to the HFCs, now to these HFO and HFC, HFO blends. There was, like you said, always something there already out there
in play.
The building codes didn't have to be updated. There were less moving parts. There's a lot of moving parts. We're seeing this transition, this phase down affect different states. Some states have already updated their building codes to allow for the installation of these systems. Others have not. So it's not happening it's not an even rollout.
It's not across the board the way you would expect it to be.
Right. Some states you can go install an R32 mini split system right now in a customer's home. Other states you can't even stock R32 or R30. Right. But again, we anticipate by 2024 everyone being on board.
Exactly. And I really do feel for the people that are writing legislation and trying to update building codes, because they're in the same boat. Remember, when we were talking about these earlier transitions, we had time, we had years to sort through it. And sometimes we had no changes at all. Now we have significant changes in building codes. And when it does get finalized, we'll all be in the same place together. So as we're getting to this place, to this common endpoint, we're just trying to keep you aware and keep you up to date so that when it happens, you don't go, wait a minute, when did we bring in slightly flammable refrigerants, and why can't I buy a jug of R410A?
Yeah, when you walk into a supply house and you grab a condenser and it has a big flame sticker on it, you're not shocked by that. Like, hey, I didn't order this. Yeah, you did.
Yeah. Or the homeowner sees you unbox it and goes, what is that? And you go, I'm not 100% sure. How's that going to make you look?
Yeah, let me read the book real quick.
Right. So how about any questions? We got anybody else that has things that we need to talk about while we're here? Great conversation items.
Yeah, this was definitely a good audience participation today. There's a lot of comments, a lot of questions coming in.
And where's everybody from? I've seen a few people chat in there. It's always neat to see who's joining us, because I've got a feeling we have a few people out here that are from other parts of the world that have a little bit different standards. One thing was brought up was that not every country is following this. Well, we're actually starting to see a majority of the world hopping on board. So the Kigali Amendment really did bring the world together. It united the world for a common opportunity to change the future of our world, to preserve a life for our children, our generations. Things that we can do now to make a big difference.
Tomorrow, right.
Philippines, thank you so much for joining us.
Also, you point out that people from other parts of the world, when we're talking about, we're going to start using R32, people are looking at us like, we've been using that for a decade.
Yes.
what's the, to them, it's like, what's the big deal?
It's the standard. Exactly.
Right. They've been using it for such a long time.
Mm-hmm. Oh, is there a new 20 SEER? Is there a new 20 SEER, new refrigerant? Oh, well, if you want to learn a little bit more about how equipment has changed, you really need to go back and watch our show from about 4 weeks ago or so when we spent some time on SEER 2 changes with Rheem, looking at how their equipment is going to be changing, going into higher efficiency equipment. You're going to see a lot of manufacturers changing their designs. If you think this is like the big thing, this is like a piece of the puzzle, all right? So there are pieces of this whole puzzle like single stage ACs and heat pumps kind of going away quickly, moving into higher efficiency systems with inverters and multi-stage equipment, and systems using less refrigerant, designing the systems to be able to be more efficient in heat transfer so we can use less amount of refrigerant. So we have manufacturers changing equipment and preparing for A2L refrigerants at the same time.
At the same time, right.
That's another thing that we've not had to encounter before. Yes, we've had some changes. When we went from 10 SEER to 12, 13 SEER equipment, big deal. Right?
We had the same refrigerant, right?
We changed some coil sizes and off you go. You can re-rate a system by changing an evaporator a lot of times. And so the equipment didn't change significantly. We have SEER 2 going on that is getting evaluated with the new M1 standards. So it's a whole different world for equipment.
In the middle of a transition.
In the middle of a refrigerant transition.
There's a lot of moving parts.
And phase down of those refrigerants. It's not like we're making a transition to a whole new generation of refrigerants that are not on the chopping block. Let me say this. Every new refrigerant that a majority of refrigerants in our industry moving forward are already on the chopping block or components of those refrigerants.
Right?
Exactly.
There's a question that came up about would the flammability potentially increase delivery charges or transport. I will point out that all refrigerants currently A1s, no matter what, that all refrigerants are already shipped hazmat. So it's not going to make a change long haul over the road, those sorts of things, because they're already any refrigerant is a hazmat shipping.
Exactly.
DOT has policies for what we can have in our service vehicles. We already drive around with oxygen, acetylene, tanks of propane.
We've already got
these are all flammable gases.
Yeah,
so do I have to have a special license for that or a placard on my van? No. Well, DOT has something called MOT, Materials of the Trade. Yes. And what that is it's an exemption or an allowance for you to use certain things in your trade. And that allows for up to 440 pounds of flammable gases before you're no longer a technician and now you're a shipper.
I can have a 500-pound recovery cylinder 2/3 full and I'm still good.
Right. I was going to say that doesn't mean it could all be in one cylinder. They wanted to see it in separate cylinders. But again, for purposes of a service vehicle driving around from location to location, you're doing refrigeration, residential like commercial. Again, you can have up to 440 pounds under MOT before you have to have any kind of hazmat placarding or ventilation, those sorts of things.
And really, the place that we're going to see that change the most is going to be at the wholesaler level. Distributors that are actually storing these refrigerants, they're going to have either a ventilation system fits indoor, or they're going to move it outside, just like our hydrocarbon propane cylinders that we have at every hardware store in the country and half the gas stations.
Right.
You just move them outside so they have ventilation.
Ventilated cages that are locked.
Exactly. So those will be the kind of things that we see. It's not like we're changing everything that we do. We are making some changes to the things that we already do. And if we follow best practices, it's not going to be huge transitions. That's pretty much it. All right.
That was good, yeah.
Yeah, we've been over an hour and still got questions coming in. So, this is what it's all about. We love having you here. We're so grateful that we're building this community together, that you're joining us. We're having these deep conversations because there's people that probably don't feel comfortable talking about this, and that's okay. Just gather a little piece at a time. But for the majority of the people that want to know and want to excel in their career, this is the place to be. So every week we have new educators, including ourselves, to bring pieces of the industry to you from the sources directly. So we look forward to seeing you all there. We are grateful to have you in our community. And see you next week on Did You Know? The ESCO HVAC Show. Thank you for joining Did You Know? The ESCO HVAC Show. want to see some of these great presenters in person? Well, then we'll see you at the National HVACR Educators Conference, where many of these guests will be presenting live classrooms, and you'll have a chance to interact with them. Would you like to watch this show again? Hey, no problem. Just head on over to YouTube to ESCO Institute. Do you have a topic that needs clarified about some kind of a change in the industry? Well, then let me know. See Beck at escogroup.org and we'll see what we can come up with.